All right. So thank you everyone for attending. We're here at VMworld Barcelona, and today we're going to be talking a little bit about Infinio, but what we really want to focus on is a concept called content-based storage. Content-based storage is a new trend that's happening in the storage industry. It's based on some pretty interesting concepts actually out of the networking space. And what I'd like to do is explain a little bit about what it is. Most of this presentation actually doesn't have to do with Infinio directly. Infinio is based on a content-based architecture, but content-based storage is a broader trend and something that we're seeing really across the industry. So, first of all, let's talk a little bit about what I mean by content-based storage, and we'll go into a lot of detail. But at the highest level, when people talk about content-based storage, what they're really contrasting with is traditional location-based storage. Okay, so when you think about your storage array, your EMC, your NetApp, or any other array, typically the way it's organized is by location. So every time you go to store a block of data in a typical storage array, what you're really storing is you're basically writing some content, and then you're saying, okay, I know where it is. It's based at a certain block address. And so your files and your VMDKs, in the case of VMware, are really made up of a whole bunch of locations, and they put together, they describe your data. Now, a very, very different way to think about storage is actually not to think about locations, but in fact to, on the basis of what the content actually is, lay out the data in accordance with that. So imagine if every time there's a unique piece of content, you don't think about organizing the storage system by saying, okay, for each piece of content I know where it is, but instead you organize the storage system by what the content actually is. And this has a whole lot of benefits. I know it's a little bit abstract, so I'm going to go through it in a lot of detail and really explain what I mean. But essentially, using a content-based approach, each piece of content is tracked not by a location, but by what the content itself is. If Vishal was here, Infinio's founder, what he would be saying is bits have a name, not a location. And that's what we're going to be talking about today. The reason to take this approach to storage and to organize your storage not by, again, a bunch of block addresses and a bunch of locations, but instead on the basis of the content itself, there's really three reasons. First of all, it's much, much more scalable. So this whole notion of taking data and writing it to a location, that's now a mapping that you need to maintain. Okay, I've got some data and here's where it's located. If somehow the data can almost self-describe, you can get rid of that, and that leads to a much more scalable architecture. It turns out content-based architectures actually have a whole bunch of inherent built-in features, things that you would have to kind of bolt on to a typical location-based system, things like deduplication, WAN optimization, compression, encryption, what have you. Again, we're going to talk more about all of this. And lastly, there's a whole bunch of natural load balancing that comes with taking a content-based approach. Again, I'll talk to that as well. But the point is if you can come up with a storage architecture where data is described by what it is, and you get rid of this artificial mapping of data lives in a location, it ends up being very, very powerful along a whole bunch of dimensions. And again, we'll explain what I mean. Okay, so let's get to the nuts and bolts a little bit. I think we've kind of talked at the theory level what content-based storage is, but how does it actually work? So content-based storage is all about utilizing hashes. And for those of you who aren't too familiar with hashing, what hashing is essentially a function that allows you to take some data, and then based on what that data is, you get a unique kind of shorthand value that describes that data. And so once you've calculated a hash on a piece of content, you know whether or not you've seen it before, and that hash becomes a unique identifier, so you can use that hash to decide where you're going to actually go put the data. So this is the most foundational thing to understand about content versus location storage. Instead of a block of data comes in, and I say, okay, to organize and think about that block of data, I'm going to assign it some arbitrary address. Instead, we calculate a hash, which is a unique value generated from the data. And if we see that data again, we're going to get the same hash value back. And if there's actually, call it two different VMs that have two completely different VMDKs sitting below them, if they have the same content, when it runs through a hashing engine, you're actually going to get the same hash address. And so that's kind of the basis of how the deduplication works, and we'll talk a little bit more about that. So at the heart of content-based storage is hashing, which is a well-known construct in storage and in computer science. So now this concept of hashing, reading some data and calculating a shorthand value, there's many such algorithms, hash algorithms out there. You need to make sure you choose a good one. And there's really two things that you're going to be looking for in a hash function if you're building a content-based storage architecture. First of all, you better make sure that the hash is very, very unique to each block of data. So if I take, call it 4 kilobytes of data and I calculate a hash value on it, the only way I'm going to be tracking the data is by what that hash value is. There's not going to be a location. So if what we end up, if you have a hash function where 2 different 4K blocks of data end up giving you back the same hash value, you can be in a lot of trouble because it's your only way of understanding where data is and what data is in a content-based architecture. And so you need to be very, very careful that your hash values are always unique on the basis of the data. And that's not a very big challenge because there's lots of hash algorithms that are extremely unique. The second thing is I mentioned that content-based architectures scale very well and avoid certain hotspots in terms of planning the architecture. And that's because it turns out that a good hash function is very unique in the sense that if I just change a couple bytes of my 4K block of data, I'm going to get a totally different hash value. And so the way to think about it is if you have a good hash function, the hash value that comes out of any 4K block is truly random. And so what that means is in your system, what you're going to end up doing is if you organize everything by these hash values, is you're going to randomly distribute the data, and that's going to avoid hotspots and lead to much more scalability than a traditional location-based storage architecture. So you got to make sure to choose the right hash function. As I said, this typically isn't a big concern because lots of such hash functions actually do exist out there. I think whenever we're talking about storage and we're talking about persistence, one of the big questions that always comes up is data integrity and is your data safe? And it turns out that this is really not a concern. First of all, hashing in this concept of calculating these shorthand values on the basis of what data is very, very common. It's actually used quite a bit in storage architectures today. It's used quite a bit in security architectures today. So you're most likely already doing a good deal of hashing on your data inside your data center. Now again, if you choose a good hash function, of which there are many out there, you can pretty much rest assured that you're not going to, with any 4K block, any 2 4K blocks, you're going to get the same hash value. You can rest assured with a good hash algorithm, every 4K block or every, I'm just choosing 4K as an arbitrary block size, but really any block, you're actually going to get a different unique hash function. And so long as the hash functions are always unique, so long as the data itself is unique, you're going to be okay, and you're not going to you're not going to end up in a scenario where you misread a block. And if you just look at how hash functions work without me kind of going deep into it, it's very, very unlikely. It's actually probabilistically impossible. I go so far as saying that 2 different blocks of data are actually going to generate the same hash value. If you think about a hashing algorithm like SHA-1, for example, if you just read about it in Wikipedia, you'll see that the collision space is very, very unlikely, and therefore your data is extremely safe. So really 2 arguments in the data safety. First of all, you're already using hashing quite a bit in your data center today, and secondly, really with a good hash function, it's probabilistically impossible that you'd have what we think of as a collision in the hash space. So it's absolutely safe. So I mentioned one of the features of content-based storage, and it's actually quite inherent to content-based storage, is deduplication. So again, if you think about a typical VMware infrastructure, what you have is you have a whole bunch of VMDKs. The VMDKs are essentially local disks for each VM. And so if you've got 30 different VMs, each one of those VMs, and it has its underlying VMDK, and in the location-based storage architecture, it's described by its own 30, each one of those 30 VMs is described by its own set of unique addresses. So, for example, if there's 1 million blocks, I'm just choosing a random number, associated with each VMDK, you've got a total of 30 million unique addresses that you're managing in a location-based system. And that's exactly what you would expect, because again, each VM thinks of the VMDK as its own local disk, and so it would want its own address space. Now, in a content-based architecture, what we are talking about is we're not actually so concerned with these locations. We're not so concerned with these block addresses. Instead, we're organizing all the storage and all the data on the basis of what the content is. And so in a content-based architecture, if you have 30 VMs, but let's say they're all running Linux, well, when the blocks describing Linux actually come into the storage system, you're going to calculate the hash value. You're going to see it's the same for all 30 of the VMs, and you're only going to store the block once. So, effectively, you know that if the hash values for two different locations, from two different VMs, actually result, if the hash values are actually the same, you actually know the block is the same, you only need to store it once. And so again, content-based architecture is inherently dedupe, so they're kind of two sides of the coin, and it's a very, very powerful feature of these systems. I'd mentioned that in addition to deduplication, there's other features you get, right? And it's all, again, it's because we're looking at data based on what it is, not on where it is. So we get things like built-in WAN optimization. If I've got to, if I've got to get data across a WAN, well, the data may already live on the other side. If all I'm thinking about is location-based addressing, I might not know that the data lives on the other side because it might be associated with a different VM. But again, in a content-based system, I'm going to calculate the hash value, and I'm going to say, oh, these hash values match, and I'm not going to resend the data again. I'm actually just going to have to send some sort of mapping that describes what I want. So it's a lot better. Now, hashing does come at a cost, and these content-based architectures come at a cost, which is that you've got to, in real time, be calculating these hash values so you can organize your data on the basis of content. It turns out, though, that this is not as expensive as it once was. In particular, most CPUs actually have specialized hardware that does hashing. So this is a very, very cheap operation, and as Intel packs more and more cores into each CPU socket, you can really rest assured that you've got the power to do this. So, storage really grew up in a location-based world in part because storage was in a compute-constrained world, but as we've all seen, this has really changed, and now compute is in abundance in a lot of cases, and on top of that, hashing is a very, very efficient use of compute. So there's no reason we shouldn't all be building content-based storage architectures. So in addition to the deduplication, one of the other great things about content-based architectures is I mentioned that they avoid hotspots. They really distribute data very, very evenly. And the reason is because if you choose a good hash function, which you always would in a content-based storage architecture, the hash value is essentially random on the basis of the content. So I only have to change, if I have a PowerPoint and it's made up of a bunch of blocks, and all I do is change a couple things in that PowerPoint, the blocks that have changed will actually get completely different hash values. So the hash values have no bias to the size of the change. All I have to do is really flip a couple of bits, and the hash values are totally different. And this ends up being very, very powerful because what it means is you can come up with a scheme for how you actually distribute data on your storage backend. So I have an example here on the slide, which is, hey, if the last digit in the calculated hash value is 1, 2, or 3, put it on node 1. If it's 4, 5, or 6, put it on node 2. If it's 7, 8, or 9, put it on node 3. And again, that last digit is equally likely to be any of those numbers because the hash values are very sort of random based on what the content is. And therefore, what's going to happen is as blocks come in, they're going to get equally distributed across the entire system. That means if you have one VM that's really acting up and really demanding a lot of I/O, it's not going to create a hotspot and actually just really hammer one of your storage nodes. You're actually going to get very uniform distribution of the data, which creates a very highly scalable system. I think this is sort of obvious from what I'm saying, but the idea here is, again, everything's about retrieving data by these hash values. So you look at the hash value, which we sometimes call digest, and that's how you determine, okay, here's where I go to get the data. So again, I've covered most of this, but again, good hash functions, you know that it's equally likely that you're going to get a digest that ends in any of the digits. This means the content's going to be equally distributed. You're not going to have hotspots. And again, the only thing we have to manage from a building a storage system perspective is we just have to manage this mapping between digests and nodes, which is a very, very easy thing to update as we add nodes. So the system is very scalable, and not only that it's equally distributing data, but then as you add additional nodes, it's very easy to change the mappings around. It's really just manipulating the metadata. So again, very, very good scalability benefits of taking a content-based approach. So what I'd like to do briefly now is just switch gears a little bit and talk about Infinio. Infinio is actually, we do not build a primary storage array, so we're not shipping an actual full-out content-based storage architecture, but it's important to understand these concepts because what we are doing is we're building a distributed storage acceleration layer that's that's based on these concepts of content-based storage. So Infinio is actually a spin-out of Columbia University. So Vishal Misra, who's our founder and chief scientist, was actually looking at the concepts of content-based architectures in the networking space. And in particular, he was looking at what's called content-centric networking. And it was really out of Vishal's research at Columbia that we saw the potential to actually build a content-based storage acceleration layer, and that led to the genesis of the company. Now, the reason we think that content-based architectures work very well for a storage acceleration or a caching layer is because of these inherent properties I just mentioned. You get things like inline deduplication kind of for free if you take a content-based approach. Well, one of Infinio's goals is to accelerate storage systems without asking you to add SSDs to your hosts. We do it with, it's software only, we just want to use the existing host RAM. Well, guess what? We all know that RAM is not available in giant quantities. And so if you can actually deduplicate inline, which a content-based architecture allows you to do, that actually allows you to make very, very efficient use of the RAM. The second thing is, and we've all experienced this in our own data centers, VMs are not uniformly used. You know, one VM might kick off a job, another one might be subject to a virus scan. And so if you can actually have this equitable distribution of the I/O across all the nodes that make up your caching architecture, it's much more scalable. You avoid these hotspots. And as I said earlier, content-based architectures also have this. So, we were really trying to make efficient use of RAM and kind of do some inherent load balancing in a storage acceleration layer. And a content-based architecture really enables both of those, which is why Vishal's research was such a good fit for creating a solution for today's modern data centers. So just to give you an architectural picture of Infinio, Infinio installs a VM on each of your ESX hosts, and then we also have one management VM. By default, we take 8 gigs of RAM per host, and then what we do is we pool that together into a giant global deduplicated layer. So it's a giant pool of cache where we globally deduplicate, and everything's perfectly load balanced because it's content-based. We also have a management VM, and that's really one per vCenter instance, so not a lot of overhead there. And then the way we do the coordination of the cache across these VMs is we actually use your vMotion network. So again, I'm going to talk about various caching architectures in just a second, but Infinio is the only one taking a content-based approach and actually creating this giant sort of pooled, globally deduplicated cache layer that allows us to get very high cache hit rates only using RAM. That means that you can offload your storage array or speed up your storage array without any new hardware. And that's really what we're offering, and that's a huge part of what it is we build and what we sell. So as I mentioned, I think it's really important. There's a lot of folks out there talking about having clustered distributed caching layers, and the reality is these caching layers are location based. They look more like a traditional storage array, and so what you really have is you have an architecture where, let's say you've got 4 nodes. Well, essentially what you're doing is each of the nodes has its own local cache, and then you sort of coordinate across the caches to ensure that you can support things like vMotion. So it's actually not a giant global cache pool like Infinio. Instead, what you have here is you have a whole bunch of local caches. Again, if you've got big SSDs at your disposal, that's probably fine. You're kind of brute forcing the problem, but it's not a very elegant architecture. When they talk about the caches as clustered, it's really about coordination. So think of it as four independent caches that talk to each other to support features versus kind of an elegant global cache. And again, that's really what we have at Infinio. So if you take those same 4 nodes, we take the RAM on each of the hosts, and then we create a giant cache pool, first of all. So it's one huge cache. And again, we take a content-based approach. So all of a sudden, you're not going to store the same block more than once. So going back to our example, if you've got 30 VMs, they're all running Linux, you're only going to store the Linux boot library one time, and that allows us to make very, very efficient use of the resources. So there's really 2 things going on. One is kind of the pooling across the hosts, and then the other is the deduplication. And I guess I could say there's a third thing, which is the equitable distribution of work, and that's sort of how this content-based layer really enables Infinio to do what it does without any SSDs or any hardware. So just another example. This is really the same set of concepts. We've got this global inline deduplicated caching layer that's based on this content-based architecture. So the example I always walk people through is why this is so powerful. Is the math really adds up. So first of all, if you've got say 10 hosts, you take 8 gigs of RAM from each. If you had 8 local caches, well, guess what? You'd have 10 8-gig caches. Instead, if you have one giant 80-gig cache, that's a way better system to have. It's a much larger cache, and as the cache size increases, the hit rate's going to go up dramatically. So you're much better off with one 80-gig cache than 10 8-gig caches. Then, because of the content-based architecture, we're doing this inline deduplication, this calculation of these hash functions. Customers see, a 5-to-1 dedupe ratio. So now I've taken that 80 gigs and made it 400 gigs. So a local location-based architecture, you're talking about 10 8-gig caches. With Infinio, you're talking about a giant 400 gig cache. And again, no SSDs required, right? You're doing this all as RAM, and you're doing this all in software. So it's a very, very lightweight, easy-to-use solution that doesn't require you to go down to your data center, doesn't require you to install these SSD cards. And so we think of our technology as really a very strong example of the power of content-based storage and content-based architectures. So Infinio customers use our software for a very, very wide variety of use cases, database applications, VDI, DevOps. I just called out a couple of examples here, in part because I think they very viscerally kind of explain, or they make it very visual why a content-based architecture makes sense. Take VDI, say you've got 50,000 desktops. Well, again, no reason to store Excel or all the stuff associated with Windows boot 50,000 times. Why store it in every one of your caches? Why not just have just one giant caching layer like Infinio provides? So we've got customers who are sustaining offload rates of 60% or more from their array. You can imagine what that does. When you're trying to roll out a big VDI deployment, we hear all the time people wanted 1,000 seats, they only got to 200 seats. But with something like Infinio, VDI becomes much more scalable because you've got this distributed content-based caching layer. Another example is DevOps. A lot of VMware actually got their start in test dev. Another great example, you've got a whole bunch of VMs compiling code. Most software companies experience this. We've got a very, very large company. Think a company whose products are probably in your house. And they were able to reduce their build times from 2 hours to about 15 minutes using this content-based approach. So they really had an option. Either they could go from a traditional storage array and maybe upgrade to a very expensive, high-cost all-flash array, or they could install Infinio. Only took about 30 minutes to install. Very, very lightweight software, and they're able to get this kind of 8x speed up on their build times. So customers see very dramatic results. And again, with the power of content-based architectures, we're able to do this all in software without requiring them to add any SSDs. So it's in my opinion, it's quite remarkable, and we're very proud of the results our customers see. again, you know, it's not just about the deduplication. It's not just about the pooling and the resources. I know I've emphasized that a lot, but it's really about this equitable sharing of work. So as you add Infinio nodes, what you're going to see is that the work is equally distributed because of this content addressing that we talked about. Things like vMotions are very seamless. You know, a VM goes from one host to the other, and it was already getting its data out of the cache from all the different nodes. You know, it was already fetching it sort of from each of the nodes because the content addressing is equally distributed, so vMotions just work naturally. There's also some advantages around cache coherency that are sort of built in, again, because these hash values are on the basis of data, not on the basis of a location. So again, as you add new ESX clusters, you scale out your performance of your compute, which is obviously quite a strong benefit. Something we've invested in, again, less on the content-based architecture, is making this very easy. Infinio installs in about 30 minutes. We install in your storage paths with no reboots. It's kind of like you click one button, you're ready to go. The software works and installs. So very, very easy. You know, we sell on the phone because it's easy for customers to slide it into their environment, kind of get the benefits of Infinio. And so we've made a big investment there. So, you know, just in conclusion, we'd love for you to try out the product. All you need is about 30 minutes of your time. You know, customers see 10x speed ups in their storage performance. They're able to offload 65 to 80% of their IOs. You know, users are a lot happier. They expand life for their storage systems. All you do is go to our website and you can download a trial and get up and running. So hopefully this has shed some light on why we're so excited about content-based storage architectures. And I assure you, we have big plans to take these concepts beyond caching and do more things. Thank you.